So if you've been looking at some of the other videos on this website, you should have a fairly good understanding now of what Opcenter APS and advanced scheduling can do. This demonstration is about some specific features for the plastic injection molding industry. This is our typical process flow. We start at one end with the plastic granules. We do our mixing and heating, goes into the mold cavity, and the mold's ejected. Now, we could model this as individual operations, but there's really not necessary to do that because it all happens in one resource, the injection molding machine. So we'll basically see that as an injection molding pass in the model. We're talking about using single molds that may have a single mold in it, or it may have multiple cavities, so you can do multiple things at a time, or we have the option of using molds that exist within a frame. We're using different plastic colors. The only thing we need to know about there is when you change a plastic color, you typically need some kind of automatic cleanup or delay so that the machines can be cleaned for the next color. Different colors may have a different setup time. The same concept exists with plastic polymers. When the polymer changes, you need a cleanup and delay. So our schedule might want to look at putting the same polymer together and then varying the color, or putting the same color together and varying the polymer, whichever makes sense for your particular industry. What are our goals? As with all these Opcenter APS models, we're trying to increase efficiency, of course. But we have to be aware of real-world constraints. For example, raw materials. I can't press something if I don't have the plastics in the right color and the right polymer. Mold availability. This model, as you will see, also has a mold shop where they are refurbishing molds. So if a mold is not available, we can't schedule it at that point in time. We also need to make sure that we have the right people to run the machine, to run the mold shop, so that we can actually follow the schedule that we create. And of course, we want to optimize our sequencing. So all that stuff we want to do, but we also need to meet our customer due dates. There's no point creating a wonderful optimized schedule if basically all your jobs are late. So we'll get into the model and you'll see all those things in our example. I've opened up the Opcenter application, and this is the landing page when you open it. This is where the scheduler themselves would do most of their work, importing data from ERP, MRP, planning, maintenance systems, whatever piece of information that we need will be imported basically behind this button. Then I would go in to generate my schedule, which we'll do shortly. And once I'm done with my schedule, I'm happy with it, I would release it out to other systems. Before we get to that, I just want to recap the slides that I showed in the beginning and where that data shows up inside the model itself. So we are talking about injection molding machines. So here are a simple list of the injection molding machines that we're working with. We also have a packing operation at the end, and then these four resources here happen inside the mold shop. So we're actually going to create two separate schedules, one for the injection molding shop machine and another one for the mold shop. When a mold shop is doing a mold cleaning or refurbishing, that mold is taken out of the pool so that none of these injection molding machines can use that particular mold. Again, one of those real world application things we need to keep in mind. The attributes that we talked about, polymers here represented with certain colors, color itself represented by hopefully the same color, and then melt temperature, which I'll get to in a minute. So a changeover group is what allows Opcenter to automatically insert changeover or cleanup time when certain things change. And of course, what we're talking about changing in this model is when the color of the plastic changes, or when the polymer itself changes, or in fact, when you need to change a mold, right? So there's two concepts here. The first one is very simple. When the color changes, we insert 8 hours of setup time. Now, that's most likely more than you need, but I did that in the demo just so it's very easy to spot. When a polymer changes, we're only doing 4 hours. When the mold changes, we're giving the molding crew 30 minutes to change the mold. So it's all variable, but that's just very simple. Something's changed, insert that delay or change over time. Now, even though I'm not demonstrating it in this particular model, we do have the capability of using the melt temperature as well, so that you can take the melt temperature and gradually increase it and gradually decrease it, rather than it jumping all over the place and you having to wait long times for the heat to change. That one is slightly different because you see it has 0 here, but if we click here, we actually see a matrix. This allows us to specify a from and a to melt temperature. So when you're increasing temperature, it typically takes less time than when you're decreasing temperature. So Opcenter basically uses the notation of what that particular job melts temperature is required, figures out within this matrix how long it takes to get to that temperature or decrease to that temperature, and then essentially inserts the same sort of concept of that changeover or the delay while the melt temperature is being changed. All of these things can work together. There's also the option of saying whichever one of these changeovers is the largest is the one we use. So if the color change takes 8 hours and we're also doing a polymer change, we're not adding the two. We're just saying, okay, it takes 8 hours. The changeover matrix, of which I only have one in this model because it's very simple, is only applied to the plastic injection molding machines. There's no changeover set up in the mold shop or on the packaging operation. So just very simple demonstration of that function. In addition to that information, we also can look down here in our supply data, again, typically brought in from ERP. So we have stock levels of our colored polymers, different kinds identified by a color and a polymer name. You can see all these are initial stock numbers because they're all available on January 10th, 2000. If I scroll down, eventually we get to purchase orders. Purchase orders available 3 days later. So as we're generating our schedule, we are allowing the ERP system to replenish our raw stock of the stuff that we need. I also have a whole series of work orders, again, downloaded from ERP. So these are the order number here, the sales order to which they belong, and you can see a whole bunch of these things I have to do. So we will go into the schedule. If you've been following along with some other videos on our website, this should look familiar to you. In case it doesn't, just a brief introduction on what it is you're looking at. The main screen here is our Gantt chart. This is where we're going to see the scheduling results. These little blocks just represent work orders that I've already scheduled. The white area, well, this empty area here basically has capacity available for scheduling, whereas the blue area here is typically, this example is probably a weekend. No working on Saturday and Sunday, so we have no capacity. That's what the blue cross-hatched area represents. If I zoom in a little bit, we can see the little black lines here. The little black boxes represent setup time. So you can see at certain points in time, setup is inserted into the sequence. That's usually, in this case, an example of when the color changes, when the mold changes, when the polymer changes, there's some setup time. An Opcenter will automatically insert that based upon the changeover matrix that we set up earlier. Down below, these little diamonds here represent sales orders. And right up the top here, this is our supply line that represents probably initial stock taken there, purchase orders coming in the future. These are our primary resources, which are, in this case, our injection molding machines, our packing, mold cleaning, CNC polishing in the mold shop. And then on the left-hand side, these are all the new orders that we typically download from an ERP. Since the last time we did this, these are new orders. They've been released, ready to be sequenced. The colors in this example are all over the place because we basically colorize the jobs based on something that's intelligent, that makes sense to the scheduler, what it is they're looking for. So in this case, we're really trying to maximize to minimize setup by keeping the same colors and same polymers together as long as possible. So I created an operation properties profile here. You can see I have various ones to choose from. I created one called color and polymer combined. As soon as I flip to that, you can immediately see just visually that I've done a good job of keeping green, whatever, together, red with the changeover there, probably the polymer, but still red. And visually for the schedule, that makes sense. Someone's looking at this and going, yeah, I got a good sequence, good color. And that's what I'm trying to use to minimize the appearance of these little black boxes, which are setup time. The gray area here represents essentially history. This is the past. To the right is the future. This is where I'm going to schedule. I've already obviously done some scheduling, and we're going to continue that scheduling option in a minute with all these new orders. Before I get to sequencing production, a couple other things to look at, a couple other tabs you can play with. This is an editor, allows you to filter and sequence and go find things and make edits and things like that. We have a plot window in the middle, which is essentially a visualization of our secondary constraints and when they're used. You can see that we are constrained in this case by number of machine operators, a maximum of 6. So our schedule is set to never need more than 6 machine operators at any one point in time. Same thing with maintenance guys. We've got a maximum of 3, packing crew, setup crew, and anything else that is a secondary constraint, we'll make sure we're constrained by it. This is the Material Explorer plot, which is essentially a visualization of the bill of materials. So this particular job here, this work order 10154 is for brown color LLDPE, needs 87.5, and it found it not in inventory, but in a purchase order that came in on the 27th of the month. That goes from injection to packing, then goes to this particular sales order. So you can track it from one side of the equation to the other. If you have an issue with the bill of materials, like I know I'm pretty sure this one does, little icons will pop up alerting you to some issue about this job. So if I actually click on this work order here, we can see that requirement was for purple LLDPE 200 units, and it couldn't find any. So there's none in inventory, there's none in a PO. Basically, that indicates a shortage, and I can tell Opcenter either schedule it despite the shortage and then report that, or in this case, I've said it don't schedule it because there's a problem I want to deal with ahead of time. So I've got all the stuff. Before I start scheduling production again, I want to make sure that none of the molds are scheduled to be taken out of service into the mold shop. So I will just go ahead and schedule the mold shop by itself. So now all of these orders out into all these work orders out in the future are for the mold shop, individual molds being taken through the cleaning, CNCing, polishing, and inspection. Then they will be released back into the pool to be available to be used in production. But right now, these individual molds are unavailable, so I won't be creating an invalid schedule by sequencing them. An important feature for Opcenter to have for the plastic injection molding model is the concept of taking the order quantity or the demand number and calculating what that means as the number of press cycles. Because you could have different number of cavities in a mold, so then the number of press cycles is actually reduced from the ERP order quantity. So let's start off by putting a couple of fields onto the screen so I can see what I'm looking at. Take the number of cavities and the number of press cycles. All right, so let's just minimize this to just filter on the number of injection runs. The first thing you'll notice is that the number of cavities and number of press cycles is currently set to 0. This model has the ability to have different molds for the same product with different cavities in a group. So you may have part number X, and it may have a mold where you can actually create 4 at a time or 8 at a time, however many that is. So we give Opcenter the ability to choose an available mold and then calculate the number of press cycles from that. So the first thing we need to do is, from an empty schedule, we'll just go ahead and forward sequence by due date. Let that run. And then the demo, I will just force the calculation. It's running in the background. Should pop up here in a second. Yeah. So you can see what it's done. If I look at the mold group, it's actually selected a mold. So each mold it has selected, there's a number of cavities associated with that mold. Therefore, we can take the ERP quantity divided by the number of cavities and come up with the number of press cycles, which influences the total runtime. You notice this is just for one particular mold. I know down here at the bottom of my screen, we have multiple molds. In this case, I set this one up just to show 4 different molds within a frame producing different quantities based upon the individual number of cavities per mold. So it can get a little complex with the numbers that you calculate, but it's very easy to insert that correct equation to verify the number of cavities I have, the number of what my demand number is, and then that generates the number of press cycles to kick out the molds when they're finished. So it's extendable, as I mentioned. I just put 4 in the demo. You can have as many molds in a frame as you want. It's just a matter of increasing the number of fields we use in the table. Okay, so now we get to the fun part. We're going to actually create our production schedule. For purposes of the demo, I'm just going to unfreeze these operations and take them off the board so I can do a nice full example. So again, the mold shop is fixed. Now we're going to schedule in various different ways just to see what's going on. The first thing I will do is sequence forwards by due date. Now this would be your typical scheduling algorithm that an ERP system would use. You've got a customer due date, a promise date. I'm going to schedule the closest due dates first and moving on out after that. Right, if you remember, we had set up our properties profile to show the colors in the plastics together. And as you can see, now here's my calculation of some other things going on. You can see they're all over the place. I've got colors, setup times, mold changes, polymer changes, and it's a mess. If you look down at my KPI indicator, the snapshot KPI, you can see I'm fairly good on on-time deliveries, 98%. I have an entire half of a day that is set up for just doing changeovers. So it's a very inefficient schedule, but if all you're cared about is the due date, then it's a fair one to run. But we're trying to do some good optimization here. So I'm going to try a different option. I'm going to pull these off the board, and we're going to look at an APS rule. There's a couple to choose from. The first one I'm going to try is the preferred sequence. And this one I've told the sequence to actually go and do colors and polymers in a sequence together. We'll see how good it can go. And I'm also going to say, well, within 30 days of the due dates, do that sequencing. So I don't necessarily want to pull jobs in that are due 6 months from now if I have them on the schedule, because that's pointless. I don't want them to push near jobs out of the window. So I'm just going to do 30 days. We'll give that a run and see what it looks like. And you notice it does take a little bit longer because it has a lot more decisions and calculations to make. So if we look vertically, you can see that it has kept initially some colors and jobs together. And that's just my cycles and number of cavities calculation running in the background. It has come through and done that. Then it's flipped over to this color polymer. So it's done a fair job of keeping the stuff together. Not too bad. My span is about the same. Half a day. It's actually less, but the number of digits that you see is only shown to 1. But I've dropped my on-time deliveries a little bit, so not necessarily the best option to run for that particular sequence in the data that we have. So we'll try one more, and we'll go try a different APS rule. This time we will let Opcenter minimize the setup. What it's doing, referring back to the changeover matrix that we had on all the changes, Opcenter will actually go through and recognize where the changes are, move things around itself to actually put stuff in the right sequence to minimize the overall setup number, again, with a window. I don't want to do that for every job I have if I have jobs months out. We'll let that guy run. And visually, you can immediately see it's done a much better job of putting colors and polymers together. I have a lot less setup time. It's just, again, in one significant digit, 4 days of setup time instead of half a day, 0.4 days instead of 0.5. My on-time delivery is actually increased by 1%. So it is definitely a much more optimum sequence. Visually, just the scheduler can look at this and say, yes, this is very good. I'm keeping the same red, I'm keeping the same yellow, green, etc. I have one job that's identified late there because the little red line on top. I have 1 or 2 jobs, 99% on time is quite good. The job that I mentioned earlier, these jobs are sitting in the unscheduled window. This is typically an identifier for something having a problem. If I show that in Explorer, that one had a shortage. So I told the system, don't schedule it. I wanted that visual clue that there's a problem. So now that I've got that schedule, I can drag and drop if I want to. It wouldn't make much sense to do so, but I'm going to just leave that where it was. I'm going to save my schedule, and then I'm happy with this. We're going to push this out to other systems. But before I get to that, let's take a look at a report. We want to look at a dispatch list. So this is the machine dispatch list. This is the schedule for this particular plastic injection molding machine. You can see the work order number, what the operation is. They're all injection runs, start times and end times. Each machine will have a dispatch list. And if I get further down, we will get into the mold shop. The mold shop has its own schedule. So every one of these reports, they're SQL Server reports, very easy to modify and add and add your own reports and things like that. So I'm happy with the schedule. I'm going to exit. Now that I'm back here, I'm going to release the schedule. This is basically going to take the results of that schedule that we just created, for example, the dispatch lists and all that, send it to typically an ERP system or an MES system, deliver reports, do whatever you want to do. We basically, behind this button, we can do all kinds of tasks. So now that schedule that I created has been sent as the current production schedule to all the systems involved. So that's an example of plastics injection molding. A couple of things that we talked about. The system has been modified to deal with cavities, molds, the color sequence, the polymer sequence. Typical, this is all standard Opcenter. We can get a lot more complicated with this, as I mentioned, with the melt temperature if necessary. But that should give you a fair idea of the capability that we do have within Opcenter to apply a plastic injection molding system.